All right, this is problem number 6 from chapter 5 of the Halliday and Resnick textbook. We've got this tug of war. Alex, Betty, and Charles are tugging on this tire here. And we're given some information. We're trying to find the magnitude of Betty's force. So here's what we're going to do. We're going to put in a little coordinate system. So Betty's force we're going to assume is along the y-axis. And then, our x-axis obviously runs horizontally. All right, so what we know is that the force of Alex is 220 newtons. And then you can do a little bit of math. We know that this here is 90 degrees, and that the whole thing is 137 degrees. So that means that this angle up here is going to have to be 47 degrees. So what we're going to do is we're going to take Alex's force and split it up into the components. In other words, write it in unit vector notation. And so we end up getting negative 150, I'll just leave it at that, I plus basically 161 j. I'm lopping off some significant digits that I kept track of. This is why I'm hesitating here. All right, so there's Alex's force in unit vector notation. Now, Betty's force we don't know, but we do know that, one, I forgot my arrows, my forces, as I always do. We don't know Betty's force, but we do know that the I component, the X component of her force is 0, and we're looking for her force, which is in the J direction, right? And then the last thing we know is this, that the force of Carl has both, an X component and a Y component, and we don't know either of those. So the force of Carl in the X direction plus the force of Carl in the Y direction. All right, so those are our three forces written out in as much detail as we can in unit vector notation. All right, so the big deal here, though, is that we know this. Well, two things. One, I forgot to write this down. We know that Carl's force has a magnitude of 170 newtons. That the tire remains stationary. There we go. I knew it was in here somewhere. Tire remains stationary, right? That's huge, which that tells us that our net force is 0. So when we add all of these guys up, our net force has got to be 0I plus 0J. All right, so I shrunk those down to give us a little bit of room. So now what we can do is just use, some simple algebra to figure out our missing guys. So this column right here, holy cow, look at this. That tells me that negative 150 plus 0 plus the force of Carl in the X direction is all got to add up to 0. Oh, cool. That means the force of Carl in the X direction has got to be 150 newtons, right, in the I direction. Okay. All right, now I can, let's see. I've got this other equation over here, but I've got this other, column over here. But I've got two unknowns. I don't know either the force of Betty or the force of Carl in the Y direction. But we can make a vector triangle for Carl. So here's what we know. We know that the force of Carl was 170 newtons. We just figured out the horizontal component of his force was 150 newtons. So I can use a little bit of Pythagorean theorem, right, to find this missing guy, the force of Carl in the Y direction, right? So, a squared plus b squared equals c squared. So we're going to get, what, 150 squared plus force of Carl in the Y direction squared equals 170 squared. When we solve that, and you'll figure out that the force of Carl in the Y direction is, now it turns out to be pretty close to 80. It's like 79.926. In the interest of time, I'm just going to do 80 newtons in the J direction. Okay. And so now finally, since we know Carl's force, we can write our last equation. So, we have a little space here. All right, and so now we know, using this column, we know that 161 newtons plus the force of Betty plus the force of Carl in the Y direction, which is this 80 newtons, has got to add up to 0, which means that the force of Betty has got to be negative 241 newtons, which just means 241 newtons. What were we trying to find? The magnitude? There we go. Technically it's negative, right? But there you go. Cool.